Welcome back in, guys. It is Thursday, April 11th. Hopefully, Wednesday was a relaxing day, a nice kind of mid-break as you got back from spring break. As you can see, same fit. It is still April 1st, April Fool's Day for me. We're knocking these videos out back to back to back. Me and Dogosaurus back here. Hi, Samson. Sam. There he is, up here. Hi. We're knocking them out. Hopefully you guys are having a nice week back. Things aren't too crazy. You're enjoying hopefully the weather is still as nice as it is today. It's beautiful. Hopefully spring break, when you're hearing this, the weather stayed beautiful and everything went really well. Congrats or non-congrats to some of you guys who won the bracket challenge. Tuesday night was the women's final. Monday was the men's final. Your bracket outside on the board should be caught up to about the final four. But if you are the winners, congratulations. I'll be getting your shirt sizes next Monday for your winners, men's and women's. Hopefully you're excited about that. Hopefully you watch some games. Right now, it's April 1st, and so all I have is the Final Four. We have some upsets, some high seeds going into the Final Four for men. Right now it's UConn, Alabama, NC State, and Purdue, I think, in the men's and the women's. It's actually Monday afternoon here. I'm actually going to the UConn and USC women's match tonight. So I can't remember who has USC. I think Ryder PB, I think you have the UConn women. So I'm going to actually be there watching them tonight. So you guys are watching this on a Thursday, but it's already all happened. But for me, it's very exciting because we're going to that game tonight. I get to go. It's in Portland at the Moda Center, so we get to go and watch some of the best women's basketball players in the world play tonight. It's very exciting. So again, congrats to your winners. I hope everyone had a great time watching some games and following the bracket and looking at what happened. If it ended up being UConn and South Carolina, the odds of the heavy favorites winning both is high. Well, again, but I don't know the results. You guys know I don't know the results. So and if you guys don't know, if nobody knows in the class that you're hearing this in, Mr. Nixon, you could pause and look it up and see who our winners were. Hopefully the winners know that they won, but they may not. So today we're going into populations and sampling. So essentially the idea is, how do you get data from stuff and how do you make sense of that data? Okay, so when we're talking about population sampling, okay, well, what is a population? Okay, so let's start with this guy right here. Okay, we have 2,468 registered voters in Morgantown that are voting on whether to build a new stadium. Speaking of sports, Morgan and her friends want the town to vote in favor of the stadium. How can they determine how the voters will vote before the day of the vote? Okay, and so okay, so when we're talking about a population represents everyone in an informational set. Okay, so in this instance, the population is her town. Okay, so we can start in on our page today. We can pop a definition here. What is a population? Well, a population is all you'd think, when you're talking about population of a town, you're talking about the number of people in a town. But when it comes to sampling, a population is all, let's see, what's the best way to put this? All of the, oops, two S's impossible, possible all of the possible places to get info. Okay, so in the instance of voting, if they have 2,400 people in the town and they want to know, how these people are going to vote, the population that they're sampling from is all the voters, right? All the places they could get info from, right? The people. Now, if they're, looking at, 250 different video games and they want to know which ones are violent and which ones aren't, the population would be 250 video games. And I think the most important word in population is All. It represents all the pieces of information. Okay. Now, obviously, in order to get a sample from this, it isn't feasible for them to ask all 12, 2,400 some odd people. So we take what's called a sample, okay? Which is, there it is. A sample is a subset of the people that can be asked to try to get information based on, what these people think, okay? So our second piece of information today is a sample. A sample is a subset, and it is smaller, of the population. Okay? A sample is a subset of the population. Okay? So get those two main ideas down in your journals. Okay? That's going to be worth a stamp. Just having those two definitions. Because when it comes to population and sampling, guess what? Population and sample, the two most important pieces of information. Okay? So she wanted to, see how these 2,400 people were going to vote. She could find a random sample of these people that would represent they could represent the data. Okay. Now, the question is, how do you make sure that the sample that you take is representative of the population? Okay. Well, we want to make sure we focus on what's called a random sample. Okay. And a random sample essentially guarantees that the info that we're getting is representative of the entire population. Okay, we have two different types of samples. We have a random sample and we have a representative sample. And these are going to be your other two pieces of information we're going to be putting into our notebooks here. Okay, so she decides she wants to survey the people in the town. How can she know that her results? Well, a representative sample. Okay, so here's our second pieces of info. This is going to be two stamps as well. This is a representative sample. Okay, a representative sample accurately reflects the characteristics of the entire population. Okay, so you would want to make sure you have the same amount of men or women. You'd want to make sure that you have the same amount of people over 30 and the same amount of people under 30. So a representative sample is representative of the characteristics. Okay, so this sample is a sample that reflects the demographics of the population. So for instance, if there's 1,200 out of 2,400 men, your sample should be 50% men. Okay? So a representative sample takes into account the demographics of the population, sex, age, ethnicity, things like this. Okay, the things about the population that they're taking into account. Okay, so if you have a population that's 80% men, you want 80% of your sample to be men. Okay, because you want 80% of your votes to represent 80% of the population. Okay, that's your first type of sample. Okay, the second huge one is a true random sample. Okay, this is a random sample. And this is true random. Okay, all, we'll say people because that's what we're pulling here. Okay, a random sample says that all people have an equal chance. If there's 2,400 people in the population, even if 95% of them are men, everyone has a 1 in 24 chance of being selected randomly at this population. Okay, so that's what we're trying to look at today. Those are our four pieces of info. Okay, let's zoom out here. Okay, so here's your four pieces of info. Okay, this is going to be one stamp right here, and this is going to be one stamp right there. Okay, So if you need to go ahead and pause this for 3 or 4 minutes and make sure everybody gets caught up and gets all those down, that should be the first piece of information, first two pieces, well, 4 pieces of information that you have in your notebooks today. Okay, so go ahead and pause, let everybody get caught up on that guy. Okay. All right. All right. Now, the next question we have is, how do we represent this data? Okay, and again, we want to represent this data, so that's what we're mainly focusing on today, is our representation of how do we represent data when we sample it. Okay, and we have 2 big main ways of doing that. We have what's called a box plot and a box and whisker plot. Okay, and they give it some weird name. It's not called a box and whisker. It's yeah, I don't know what they call it. They give it some weird name. I can't recall offhand what it is. Okay. Okay. So let's look at some data here. Okay. Whoops. Hold on. Gotta go back here. Okay. Okay. Let's see. Drawing inferences from data. Okay. No Chick-fil-A sauce. Okay. All right. All right. So we have, let's look at this as an example. Okay. Sasha's trying to convince her mother to change her bedtime on school nights. She gathers data on the average number of hours of sleep that a random sample of 7th grade students in her school get each night. Will she be able to convince her mother to let her go to bed later? Okay, so she looks at the sample of people that she sampled. It looks like 1, 2, 3, 4, 5, 6, 10, 14, 19, 21. It looks like she sampled 25 people and asked them, how many hours of sleep do you get per night? Okay, so you can see she makes a tally every quarter of an hour: 8, 8 1/4, 8 1/2, 8 3/4, 9, etc., all the way to 10 1/4. Okay, looks like she gets from 9 to 6:30, 9 1/2. So she falls in this area, which looks to be the heavy one. So she is trying to organize this data to try to let her mom stay up later. Okay, so you can see we take this data and we organize it into a box plot, or excuse me, not a box plot, a dot plot. Okay, it's essentially a graph where each dot represents one person. Okay, let's listen to what they have to say about it here. Representation that she can use to describe the data. So again, box plot, dot plot, they are representations visually of data. What do the dots in the dot plot represent? Okay, each dot is a person, right? Okay. It looks like that she gets. It looks like she gets about the same, doesn't she? Okay. Notice that the curve is very similar to that curve that we talked about in probability last week, right? We have a couple really lows, one really low, one really high, but most people here fall in the middle. This is that remember the guy dumping beads into that board, right? We talked about the bell curve. Okay. Sorry, Sasha, you're not going to bed later. Okay. You played yourself, Sasha. Okay. But again, so we're talking about a dot plot. All right. So let's roll over here and we'll talk about a dot plot. Okay. Is essentially, is a graph of data. Okay, a dot plot is essentially a graph of data. All right, we can zoom in a little bit on this sucker. There we go. Okay, a dot plot is a graph of data. All right, so let's have a look. Ooh, this is really good. Okay, so I'm going to put this to the side so you can see it. Oops, there's all my averages. Okay. It says that Dash collects data on the hair lengths of random samples of 7th grade boys in his school. So let's take this and make it a little bigger so you guys can see what we're doing here. Let's sort this a little different here. There we go. Okay. So we look at the information that he's given here. Okay. So here's what I want you to do. I want you to fill in these two boxes. Okay. Figure out where your data clusters are. You can clearly see they're circled in, or they're squared in red boxes. Okay. And what can you infer about the data? Okay. I want you to write these out in these two boxes. Okay. And figure out, just ignore this guy. Let's get rid of that. Okay, we'll move that up. Okay, take about 2 minutes. Fill in that information out. Okay. All right, so he's collecting data on the hair lengths of random samples of 7th grade boys in the school. It looks like the data is clustered between 1/2 and 2 and 3.5 and 4.5. Oops. Okay, what can he infer from the data that 7th grade boys in his school have short and long hair? He can infer that, right? So yeah, they either have short hair or long hair, right? The lowest amounts are here in the middle, right? No medium length hair boys, okay? So again, finding data, putting them in this box plot can help us to realize what data is relevant here. Okay. All right. This is really similar to what we were talking about with mean, median, and mode, right? Now, if you were to take this information, I'm sure your mean and your mode would be, or your median and your mean would be here. But you notice that your modes are here, and then these are secondary modes, right? And so, your mode is probably a better representation of your data here because, you see your middles are so empty. Okay, so this is kind of a situation where your mean average of your hair lengths probably would not be super relevant. Okay. Now, if I did this, for hours to sleep, well, if we calculate all these, right? If it's a bell curve like we talked about, your mean, median, and your mode should be similar, right? So like if you look at your median, 9.25. Okay, your mean, also about 9.25. So your inference is, yeah, your mean and your median are the same. Your average should be pretty similar. Okay, so see how that rolls back into what we did a couple days ago, talking about averages. Okay, so that's the dot plot. Pretty simple. Okay, you're just putting your information along the bottom, and you're just representing it as a graph rather than just tally marks as it relates to information. Okay. The other guy is our box and whisker. Okay, we're going to say box and the old box and whisker. Okay, and this guy looks like this. Okay, and I would say it's not a great definition, but yeah, a box and whisker, also a graph of data. isn't it? Okay. It looks a little different. It's a little harder maybe to understand, but not necessarily any more or less helpful. Okay. All right. So Marco and Ravi having the same argument with their parents. They're trying to get their parents to let them stay up later. Okay. They collect data about the number of hours of sleep that a random sample of seventh graders each night. The two box plots show their data. Do their data support Sasha's inference that most seventh graders in her school get between 9 and 9.5 hours of sleep? Okay, so here is the box plots. Okay, so on a box plot, here's what they represent. Okay, each of these pieces of information on a box plot, each of these chunks is 25% of your answers. Okay, so if I got 8 results, I took a survey and I got 8 results, 2 of my results would each be in one of these areas. Okay, so it could look very different. It could look, say you get a bunch of results that are at the bottom, the box plot could look like this. Right? Or say, you get this is 2 answers, and this is, say this is like you get your answers are 1 and 8 and 9, 10, 11, 12, 13, 14, right? So you have 2 answers here, 2 answers here, 2 answers here, 2 answers here, right? So your box plot might look very differently. The box might be shifted around, wherever it is, okay? The main thing I want you to remember about box and whisker, okay? Let's take about the most important information, okay? This guy right here, right? That's the median. Okay? That's the middle of your data, right? So when I look at this, the middle of their data is both 9 and 1/4. So when I look at these 2 pieces of information, okay? Their median, their mean of their data is 1/4, okay? Wherever the lines start and end, okay, that is the range, okay? So if we look at this piece of information, the range on Margot's data ranges from 8.5 to 10. So her range is 1.5, right? 10 minus 8.5, 8.5. Okay. Robbie's data, a little wider. Her lowest value she got was 8, and the highest that they got was 10.5. So 10.5 minus 8. So her or his range is 2.5. Okay. So that's the biggest thing I want us to take away from box and whiskers. Okay. So I'm going to write it again. And I would like you probably didn't write any of this. Okay. I want you to write what we have here for box and whisker. Okay, I'm going to jump up and I'm going to write here. Okay, this right here is the median of the data. Okay, and here to here is the range. Okay, and this sucker right here, this drawing, is a stamp. Okay, you will get a stamp for that. Okay, box and whisker. When you look at them, that is the most prevalent place they're going to ask you information. Okay, they're going to give you a box and whisker that's going to look like this, and they're going to say, how much bigger was Robbie's range from Margot's range? So Robbie's was 2 1/4, Margot's was 1.5. Robbie's range was 3/4 wider. Okay, how do their medians, how do their averages compare? Oh, they're the same. Okay, for now, this data, these little, these are called quartile ranges. We're not going to worry about them right now. Okay, the main place you need to understand about a box and whisker is the range, end to end, and the middle. Okay, that's where you want to focus the most. Again, the dot plot stuff, that's pretty easy to look at and notice. Okay, when we're looking at a dot plot and we want to know the range, well, just the smallest dot to the largest dot and subtract it. Okay, we want to know the median, well, you might have to do mean median mode. You might have to look at it and figure out where your median is. Okay, but with a box and whisker, again, range right here, end to end, okay, and median value. Okay, and they're going to ask you to compare them on multiple plots. This is a beautiful example of what you might see on the state test or something on the test. And they're going to ask you, how much more is her range than her median or something like that, okay? And again, being able to determine the range and the middle of a box and whisker are the two most important pieces of information that you need to know, okay? Let's look at a try it and see if we can find that here. Okay, let's most of the time, they're not going to ask you to calculate a lot of stuff with box and whiskers. They're going to give you box and whiskers with info, and then they're going to have you determine stuff about it. They're going to be like, okay, hold on. Oh, they have a split on this one. Okay, so here's one I want us to look at. Okay, put this to the side there. Okay, right here. It says the manager of a box office gathered data from 2 different ticket windows where tickets to a music concert were being sold. Does the data shown in the box plots below support the inference that most of the tickets sold were about $40? Okay, so I want you to look at this. Okay, they're asking you, does it inference that most of the tickets were about $40? Okay, take a couple minutes here and think to yourself, okay, is the average ticket $40? And how could we know that? Okay, take about 2 minutes and see if you can jot that down. Yes or no, and why? Okay, so if we're looking at this, let's make a little copy of this guy and then throw it in our paint here so that we can doodle on it. Okay, there we go. Okay, notice where your median values are. About here and about here. Okay, so does it make sense that most of the tickets were sold were about $40 out here? Look where all these other tickets are, way up here and way up here. Okay, so I would say that does not support this. The average ticket cost would be 40 or 50 or 60 bucks, right? Right about in here, about $55. Okay, now if I asked you what was the most expensive ticket sold at either window, okay, what was the most expensive ticket sold at either window? Take 1 minute, jot it down. What was the most expensive ticket sold at either window? Take 1 minute. Okay, if you looked at window 1, right here, what was the most expensive ticket sold? Let's use a line here. Most expensive ticket sold looks to be about $91, $92. Okay, and my dog coughing over here. The most expensive ticket sold at window 2 looks to be about $97, $98. Okay. Okay. Yeah. Okay. $97, $98. Okay. The cheapest ticket sold, both windows, 20 bucks. Okay. So what was the range in ticket costs for both windows? 20 to 95, about 75 bucks, right? Okay, good. About 75 bucks. Okay. Let's look at one for dot plots here. Dog was coughing. Too many treats. Okay. Let's look at this guy right here. Okay. Carnival game. Players get 5 chances to throw a basketball through a hoop. Okay. The dot plot shows the number of baskets made by 20 different people. Sorry, my dog's coughing up over here. Let's make an inference based on the shape of the data. Sorry, I know you can hear him in the background. Well, what inference can you make about this data? Well, maybe take a minute or two and see if you can make an inference. Then I want you to, what is the median of the data? Okay, how do you know this? By looking at this graph. And lastly, okay, don't worry about that. Okay, what is the median? So take about a minute. We'll go through that. So what inference can we make about the shape of the data? Well, that the majority of people make 2 to 4 baskets, right? Okay, right about here in the middle. And that there's an average number that make kind of all the way in between, okay? And secondly, what is the median of the data? What is the mean? Do these measures of center support the inference you just made? Well, what's the median? Okay, we have 5 here, we have 7 here, so 5, 6, 7, 1, 2. So your median is about here. So let's grab this fella so we can throw it in paint here and talk about it. Okay, so your median's about here. Okay, and if we take all our pieces of info and we add them up, 1 plus 1 plus 1 plus 2 times 4 is 8, plus 3 times 4 is 12, plus 4 times 4 is 16, plus 5 times 3 is 15. Okay, 54, and we have 20 people. Yeah, your average is about 2.7. Look, it's about in the same place. So the inference that they made somewhere in this area is pretty good, okay, overall. Okay, so yeah, there you go. Okay, so taking information. So again, being able to take info from your dot plots and find mean, median, mode, range if you have to, and being able to take what you have from your box and whisker and being able to solve data from that as well. Okay. All right. So those are your 3 things where you're going to get over here. You're going to get, we'll go 2 stamps. You'll get 1 for having this and then 1 for having those things that we just did. So let's say 2 stamps today. Okay, when we come back. So Thursday is 2 stamps. Okay. Thursday is 2 stamps. Okay. And we'll be back tomorrow. We're going to be doing what we just did, looking at some population sampling, box and whisker plots, dot plots, etc., etc., etc. So, Barrett signing out. Enjoy your Thursday. Might be spaghetti today. Maybe, but or something weird. I know that there were some fun lunches this week. I was actually sad that I'm gone this week, and I was like, there's a island taste of the islands or something like that. It looked really good. Maybe you guys have already had it. Maybe you already haven't looked at the schedule. So enjoy the rest of your Thursday. I'll see you guys tomorrow for our final item on Friday, and signing off.